Mm-hmm.
Hello, hello, hello everyone. I hope you're doing well. In this video, we are gonna calculate this summation. This is the part 2 of this video where we had to calculate the second order energy correction for the nth state of linear harmonic oscillator with falling perturbation. And we have seen that we had equation number 2 where we had this summation and another summation was this one. We calculated this summation in part 1 of this video, and now we are going to calculate this summation, which is we can see here that something that we need to calculate, and after we have calculated it, we can plug those values right back to in this equation to get the second order energy correction for the nth state of linear harmonic oscillator. So that is what we are gonna do in this video. We can see here that we have this summation right here, and let's quickly get started with calculating this summation because that is all we need to do here. Just as we did for the calculation of this part, okay, which is this one, we are also interested to find out this scalar product first, and after finding out this scalar product we can find out that we can calculate this whole thing. So first of all, we should know what this thing is equals to, and for that purpose we'll again let the position operator to be equals to the ladder operators, the raising and the lowering operators. So let position operator is equals to h cut by 2m omega under root into a plus a plus. Okay, this is the lowering operator and this is the raising operator, and this is the standard substitution. It is always in this form. Okay, this is not some random substitution. It's actually a standard substitution that we make every time in order to express a position operator in linear harmonic oscillator in terms of its ladder operators. So we need x to the power 4. Okay, so what we will do is to take power 4 on both sides. So it's h cut by 2m omega a plus, so it's simply whole power 4 on both of these quantities, and we know that h cut by 2m omega under root is actually 1 by 2 power, so multiply by 4. Powers multiplies when we have such a situation. So 2 ones are 2 and 2 twos are, so it's h cut by 2m omega whole square into a plus whole 4 power. Now here we have h cut square, we'll just open up the square, so it's 4m square omega square, and we can write this expression as a into a plus a plus whole cube. All right, we can write it like that, and I'm writing it like that because we have already calculated this thing. You'll see what's gonna happen. In this way, we have wrote the position operator in terms of its ladder operators, and now we'll apply this operator on the ket vector which is on its right hand side, because operators only applies on the wave functions or kets which are on its right hand side. So this is the ket vector that is being applied by that is being operated on by this operator. So let's apply operator. Applying operator x4 on ket, which is this. So that means we are multiplying this ket on both sides, a plus and a plus whole cube into ket. All right, and now one of the hectic thing is reduced because we can see that these are, we can write the result of this thing because that is something that we already calculated in this calculation. Okay, let me mention here. You can see here that this is x cube into n, and x cube into n was actually it was actually this thing. Okay, x cube was actually equals to this whole thing times this. All right, so it means that whatever we got for this thing, Okay, other than this, not, we will not include this one part because that is not we need. So all the results, the result that we got for this one thing in this part, we can write it here directly because that is what we have in here as well, that we have already calculated in previous calculation. So I'm going to use that one result into here. So let's see what that result was, and we can just insert the value right here, that let's say it is equation number C. So let me mention here that what was that term equals to, because I don't have that page right now. You can see during 41 minutes and 48 seconds, this at this point of that part 1 video, I have mentioned this term here. Okay, and I'm not including that 8 cut sum and divided by 2m omega whole power 3 by 2 because that is not needed, because here the constant is different and that is not required as well, because we want only this value, and that is actually equals to this term. You can see at this point of the video. All right, so we can use it right here as well. And before using it and inserting it into equation number C, we need to do one thing, that is to simplify the similar cats. As we can see here that we have some similar cats here. We have this cat that is n minus 1, and we have cat n minus 1 here, and another cat that is n minus 1. So we need to simplify these cats before putting it into the expression. So whenever the cats are similar, add them up and reduce them. That is compulsory thing to do. So let's do that. For the first cat, which is n minus 1, we will take cat common and the constants will be inside the bracket. So let's take, we'll write the, and another thing that we can see is common in here is under root n. You can see that under root n is common among them, so we can take under root n common as well. So besides under root n and the cat, we'll write the other things inside this bracket, which is actually n plus 1. Then plus sign we have, other than under root n and this cat, we have n plus sign, then we have n minus 1. We'll not take under root n here as well. Okay, keep that in mind. Under root n is outside and the cat is outside as well. Then plus sign, we are gonna consider the next cat which are common, and we can see that under root n plus 1 and this cat n plus 1 are common here among these three expressions, so we can add them up. And similarly we can have under root n plus 1 as well, a common thing here. So bracket starts, we have n plus 2 first, plus then the second term is n plus 1 here, plus then we have the third term which has n here, and we have under root n plus 1 into cat is n plus 1. Then we have these two different cats, so they cannot be added to each other. We'll write them right away the way they were written, and since all of them have under root, we can write them under a single under root. So it's an under root, whole under root into inside of which is n plus 1 into n plus 2 into n plus 3 and n plus 3 cat, plus we have this whole under root n into n minus 1, n minus 2, and this cat. All right, we did this thing after multiplying it with the bra vector m in the previous part, but in both ways it's correct. We are just reducing the number of steps and it will reduce the number of terms, and that is why it's always easier to do it and better to do it. We have minus 1 and plus 1, they cancels out. All right, and we have n plus n plus n, which is 3n. So 3n into under root n, and n minus 1 is the cat, plus we have n plus n plus n, which is 3n, and 2 plus 1, which is 3. So it's 3n plus 3, and we'll be using bracket here because we have two quantities that are being added to each other, and we have this thing outside, so we have to use bracket. While in this case we had only 3n, we don't need to use any bracket because nothing is being added or nothing is being added or subtracted when we had this thing. So it's this thing. We have a total of 4 cats, you can see. Before that we had a total of 8 cats, and now they are reduced into half. We have now 4 cats, and you can see that the number of terms has been reduced after simplification. So always simplify when it could be. All right, so that is the result for a plus whole cube into cat. So we don't need to do that whole hefty calculation again and again, because we can use it directly. All right, it's n plus 1 here. Okay, this is n plus 1 here. So let's put this value into equation number C here. Okay, this is the equation number C, and we know this expression is equals to this. So let's put it right here, and let's do the rest of the things that are needed. So it's x4, this is equation number C that I'm writing, that is equals to h square by 4m square omega square a plus, and then we have this whole thing. Now I'm gonna write it here. Bracket starts 3n under root n, and cat is n minus 1, plus here we can take 3 as common. So if we take 3 as common, we have n plus 1 that is left behind. Okay, if we take 3 common, so it's n plus 1, and we had under root n plus 1 already, and its cat was n plus 1 as well. Then we have this under root thing, n plus 1 into n plus 2 into n plus 3, and its cat was n plus 3 as well. Then we use plus sign, and then comes the fourth term, which is under root n into n minus 1, n minus 2, and n minus 3 is the cat. Bracket closes. Now we have to multiply this thing with this quantity. We have 4 quantities in here, four elements, and we have 2 numbers in here, so 2 operators actually. So we'll multiply this first operator with all these quantities, then plus sign, then this second operator with all of these quantities. We are basically multiplying these 2 terms, these 2 expressions together. And keep that in mind, operators only applies on cats or bras, and we can see only cats are there, so it will be only applied on these cats. It will not be applied on these constants. Constants will be written outside of the operator, so we'll write the constants outside, and we'll write the operator along with besides the cat vector, okay, on the left hand side of the cat vector. So let's do that. H square by 4m square omega square. So a, I'm gonna write a with all these quantities first, and then a plus. Okay, so 3n under root n, I'm writing a here with n minus 1. Then the second quantity, which is 3 into n plus 1 into n plus 1 1 by 2, under root is actually this, and a into n plus 1 plus this third quantity, n plus 1, n plus 2, n plus 3, then the loading operator on this cat, then the fourth term, the last term for a, n minus 3 cat. Now we'll multiply the raising operator, and the same thing will happen. Just in place of loading operator, we'll be writing the raising operator with all these 4 quantities. Raising operator, then 3 into n plus 1 into under root n plus 1, raising operator on n plus 1, then this under root term, a raising operator on n plus 3, plus the last term, which is this, and a plus applies on n plus, n minus 3. Last term is n minus 3, and the bracket closes. Okay, a total of 8 terms. Now let's calculate what these lowering and raising operator when applied on these respective cats equals to. Okay, let's find them out in a separate rough part, and we'll directly put those values into these expressions one by one. Okay, so let's calculate and let's calculate it, and we'll be calculating it using those relations between the raising and the loading raising the loading operator. For example, when loading operator applies on any cat, we get a constant term which is under root of what was written in here, and the cat was, if the cat was p before, it becomes p minus 1. Okay, we'll reduce it by one number. And similarly here, when raising operator applies on p, we get constant term raised by 1, and we get the cat raised by 1. Okay, that is simple. So there is only difference that in only in lowering operator we get the this constant while it is reduced by 1. So let's do that and see that what does it equals to. Let's call it as equation number D, and let's see what it equals to. So the first is when the lowering operator, first is lowering operator is applied on n minus 1. So in lowering operator we get the constant the same as it was in the cat. Okay, while in its cat it's this cat minus 1. Okay, reduce it by 1, so it's under root n minus 1, and it's n minus 2 then. Okay, that is a n minus 1. Now we'll apply a on n plus 1 because that is the next cat here. So we'll get the same as it was here. We'll write this cat here and reduce it by 1. Okay, we'll do the same thing for every time when we are applying the lowering operator. Plus 1 minus 1 cancel, so it's n only. Next we have the lowering operator applied on n plus 3, and in constant we'll get the same as the number inside the cat, and the cat will be reduced by 1 under root n plus 3, and it's n plus 3 minus 2 is plus 2. Now we'll apply the lowering operator on this, so it's under root the same as it was here, like that, and n minus 3 minus 1. We can see the same trend, and it's really easy to calculate. Okay, these are all the values for the application of lowering operator. Now let's do it for the raising operator. We have same cats but for raising operator, so it's n minus 1 first, and we know that we'll add 1 inside the constant as well as inside the cat. So it's n minus 1 here, we'll add by 1, n minus 1 here, we'll add by 1 again. So minus 1 plus 1 cancels, it's under root n, and here n as well. Now it will be applied on n plus 1. So we'll write the cat first, which is n plus 1, here the cat first, which is n plus 1. We'll add 1, and we'll add 1 here as well. This is how the raising operator applies. So it's n plus 2. That long under root was not needed, but yeah, that is it. Now third is raising operator applied on n plus 3 cat. N plus 3 cat. So what we got is under root n plus 3, add by 1, n plus 3, add by 1, add 1, n plus 4, n plus 4. Last is a plus applies on n minus 3, so it's under root n minus 3 plus 1, cat n minus 3 plus 1. So it's n minus 3 plus 1 is minus 2, n minus 2 cat. Let's put all these values right back into the expression number D. Let's solve them, simplify them, and see what we are gonna get. So it's x to the power 4 n. Alright, so it was x to the power 4 here. Okay, in this page it's x to the power 4. Okay, x to the power 4, that is equals to h cut square by 4m square omega square 3n under root n. Then we have the first operation, that is actually equals to this quantity under root n minus 1, and cat is n minus 2. Okay, then plus sign, we have second term which is this, plus 3 into n plus 1 into under root n plus 1. This ket, okay, it is actually equals to this thing, under root n plus 1 into n ket. Okay, next we have the third term, which is this under root term. Let's write it down, plus under root n plus 1 into n plus 2 into n plus 3, and that is the third term, as this operator in this thing actually equals to under root n plus 3 into ket is n plus 2. Now the fourth term is that n into n minus 1 n minus 2, and its operator in ket, when it was calculated, it was equals to this. So it's under root n minus 3, ket is n minus 4. Now plus sign, we have these terms are written, okay, we have wrote them here. Now we have this term, it's 3n under root n, and the raising operator applied on n minus 1, which was equals to under root n into n ket, plus 3 into n plus 1 into under root n plus 1, and we have this raising operator applied on n plus 1 ket, and that is equals to under root n plus 1, oh sorry, n plus 2, and ket was n plus 2 as well, plus this whole under root thing, n plus 1 into n plus 2 into n plus 3, and we had raising operator applied on n plus 3, and that was equals to this thing. Let's write it down here, under root n plus 4 ket, plus the last term finally, okay, and raising operator applied on n minus 3, that was equals to this. So yeah, n minus 2 and n minus 2 is the ket, bracket closes. Now we need to simplify these terms which have the same kets, okay, and let's see which terms have the same kets. And we can see that we have that ket n minus 2, this ket is n no, n plus 2, n minus 4 ket, n plus 2, n plus 4, oh yeah, this is the n minus 2 ket, okay, these two kets are similar, so let's take them together, let's put them together and we'll write them. Let's do that, okay, and it's 3n under root n and under root n minus 1, and then we have this ket, okay, I'm writing it first, I'm writing them together first, and then we'll take the ket common. So this is the whole thing, then plus what we can do here is to separate the square root on all these quantities because that is needed. So it's under root n, then under root n minus 1 second one, and we have under root n minus 2 this one, and we have this under root n minus 2 as well, so I'll take it as square, then this ket, okay, n minus 2, it's the ket with this thing. And next, let's see, we have did that. Now let's see the next common ket. We have this n ket here, and we can see this n ket here, and none of the other kets are similar, so they are similar to each other. Let's write them together. It's 3 into n plus 1, and we can see 3 into n plus 1, and we can see under root n plus 1 into under root n plus 1. We can write it as under root n plus 1 whole square, and it's n ket, plus we can see it's 3n under root n into under root n, so it's under root n whole square, and n is the ket, plus sign, we have did that. Now next is n plus 2 ket, which is here and here as well, so let's bring them together. And here again we'll separate the under root on these quantities here as well, so it's under root n plus 1 under root n plus 2, and under root n plus 3, and this is under root n plus 3 as well, so we'll take n under root n plus 3 whole square, and cat is n plus 2. Similarly here we have 3 into n plus 1 under root n plus 1 under root n plus 2, and cat is n plus 2 plus, now these two cats are different, it is n minus 4, it's n plus 4, we'll write them the way they are written, no more simplification. So it's under root n into n minus 1 and minus 2, and we have this n minus 3 as well, we'll write this under root with them as well, okay, because it's under root, they have under root, so we'll write them together. And minus 4 plus the last term, we'll write the n plus 4 factor inside of this under root as well, because they are all under roots, so bring them together, n plus 4 cat, and we will close the brackets here. Let's simplify them, because we can see that the things that are happening in here. So we can see that this square and under root cancels out, okay, and it will happen with all these terms whose square and under root are together. So this square under root cancels, this square under root cancels, yes. So let's do that. It's h cat square by 4m square omega square. All right, so you can see here we'll take something common, and since both of them have similar cats, I'll take the cat common because we have same cat in both these quantities. Other than that, we have under root n minus 1 here, under root n minus here as well, under root n and under root n here as well. So we'll take these three quantities common out of both these quantities. So we are left with 3n plus 1 because there is nothing else. So oh yeah, it's n minus 2 here that is left. So it's 3n here plus n minus 2, and we'll take these three outside of the bracket. So it's 3n plus n minus 2. It is the one whose square and under root was cancelled. So this quantity, and out of it is under root n minus 1 and n minus 2 as the cat. Then we have plus sign. Now let's see the next term in line, which we can see the cat is n, and we can see that nothing else is common in here. 3 is common, so we can take 3 common, and yes, that's all we have. So let's write them. We'll write n plus 1 into n plus 1, since square and under root was cancelled, so it's n plus 1 into n plus 1, which is n plus 1 whole square, and n plus 1 whole square, n plus 1 whole square, we took this and this common, so nothing else left, plus we have n and this n, square and under root was cancelled, so it's only n into n, it's n square, so we have n square here only. 3 was taken common, so we can have 3 and this cat. Okay, next is, we can see the next term has this cat which is common. We have under root n plus 1 and under root n plus 1 as common, under root n plus 2 and under root n plus 2 as common, and we'll write the rest of the things, which are here square and under root was cancelled, so it's n plus 3 which is left, nothing else is here, so we'll write n plus 3, right? Don't need to add any bracket because this is all we have, nothing else is being multiplied to it, so it's only n plus 3, and here we have 3 into n plus 1, and rest of the three terms are taken common, so it's 3 into n plus 1 plus 3 into n plus 1, bracket closes, and we have under root n plus 1, under root n plus 2, and n plus 2 is the cat. All right, and they will be written the same way, nothing else changes here, nothing changes here because n minus 1 into n minus 2 into n minus 3. Cat is n minus 4 plus under root n plus 1, n plus 2, n plus 3, n plus 4, n plus 4. Now let's simplify it. It's h square by 4m square omega square, and it's 3n plus n, which is 4n minus 2 into under root n minus 1 and n minus 2 as it is, then plus sign. We can add them together. Okay, if we open up the square, it's n plus 1 whole square, which is equals to n square plus 1 plus 2n plus n square, which was already there, and 3 into cat. Plus then we have this term in here, which is n plus 3. We can multiply this 3 inside, so it's plus 3n plus 3, 3n plus 3. And then we have under root n plus 1, under root n plus 2, n plus 2. Plus then we have this whole quantity. It will be written the same way because there is nothing to solve here. It will be solved in the summation part, okay, and the square part. Just writing them away, and yeah. Now let's simplify another time. It's h square by 4m square omega square 4n minus 2 under root n minus 1, and cat is n minus 2 plus it's n square and n square, it's 2n square plus 2n plus 1, and we have 3 outside. We can write 3 here, then cat is n plus then this quantity we have n plus 3n, which is 4n. 3 plus 3 is 6, so 4n plus 6, 4n plus 6 into under root n plus 1 under root n plus 2 n plus 2 plus these two terms. Again I write it like that, okay, I'm not writing it. You are supposed to write it the way they are, okay, write them yourself. So that is the x4n so far. It's n plus 4 here, okay, it was n plus 4 here, and now it is the point where we'll apply the bra vector, because the quantity that we want to calculate is actually this quantity. So we have calculated this part. We'll apply the bra vector on the left hand side. Simply it will be equals to this term, and we'll just write the bra vector with the along with the cat vectors, and we'll get this expression. And let's write it. Let's see what this thing equals to, and then we'll put this value into this expression, and we'll simplify it, and we'll get the result. So this is actually equals to, we'll simply multiply the bra vector on the left hand side, and we'll get the expression. So it is actually, I'm multiplying the bra vector on the left hand side, and since it's a bra vector, so it will be written with these cats, okay, we'll write them directly with cats, and the constant will come outside. So it's 4n minus 2, okay, we have a constant first, which is h square by 4m square omega square, and then we have 4n minus 2 under root n minus 1, and we have this bra first, and then we write its cat, which was n minus 2, okay, its cat, we'll write bra on its left hand side. There will be a same, okay, vertical line between them. You are not supposed to write this 2 times, okay, that is not valid. When there is a product, we write them with this they write them as sharing the singular line. So that is what it is, and it's simply like we'll write the bra vector with on left hand side of each of these gets, and I'm just simply rewriting it. Okay, so that is how it will be looking like. Let's write them. 3 into 2n square plus 2n plus 1 and m, and it's get 4n plus 6 under root n plus 1 under root n plus 2 and bra with its get, then plus this whole under root, which is n plus 1. Oh no, it's n into n minus 1 into n minus 2 into n minus 3 and m with n minus 4 plus the last term, which is n plus 1 into n plus 2 into n plus 3 into n plus 4, and it's bra and get, which is m n minus n plus 4. It's n plus 4 here. Okay, so that is it. That is the value of this expression. Now let's put it into this expression. Okay, let's write this summation and this division sign, and we'll have this whole term and whole square over it. Let's do that. Now this thing whole square divided by en of 0 minus e m of 0. First we'll write down the summation, which is m is not equals to, and we'll write this thing outside first, we'll multiply it inside later when we'll open up the square. Okay, and the same situation happens here as we did for the x cube operator before. So let's write down this expression, which is h squared by 4m square omega square. It's also inside, so 4m square omega square, and this whole term inside curly bracket starts 4n minus 2. I'm just simply writing it the whole thing. Okay, again, and under root n under root n minus 1 under root n minus 1, and then this is its get raw, then 3 into 2n squared plus 2n plus 1, and this is the value that I'm writing. I'm simply writing it here. 4n plus 6 into under root n plus 1 under root n plus 2 m n plus 2 plus n into n minus 1 n minus 2 n minus 3 m n minus 4 plus under n plus 1 n plus 2 n plus 3 and n plus 4, right, and m n plus 4. Okay, curly bracket closes, and this bracket needs to be closed because this is the whole, this is actually equals to this term. Okay, we can see that including this constant, this whole thing is m x4n. Okay, and we have whole square over this quantity, and keep that in mind. It has this square is over this constant as well. That is why you are supposed to write it inside the square. Don't make a mistake to write it directly outside and not taking it square. Okay, that is wrong. We can see here that this quantity has this part as well. So if this whole quantity has a square over it, so it means this quantity will also experience the joy of having a square over it. Okay, so now we are supposed to find out the square. Next we need to open up this square. As we can see, there are 1 2 3 4 and 5 terms and a whole square of it. So you must know that if we have a plus b whole square, for example, if we have two quantities and a whole square of it, so that is equals to square of individual terms, which means square of a plus square of b, and then an additional term which involves the product of these two quantities. Okay, and if we have, for example, square of three quantities, then what we have is the square of individual terms, which is a square plus b square plus c square, and then we have three extra terms, 2ab plus 2bc plus 2ca. As the number of terms inside the square increases, the terms we get, greater number of extra terms besides the square of individual terms, plus many other. And since we have 5 of them, so we'll be have many, maybe 5 to 6 additional terms. So what this square actually equals to, okay, what this whole square actually equals to, is there any shortcut to write something that is simpler? So yes, there is a shortcut. What happens in here, that we have these cat bras, and all of these cat bras are different to each other, and these represents the orthogonal states of harmonic oscillator. So all those products which involves the product of different cat bra, they become equals to 0 because of orthogonality condition. Okay, because for a similar value of m, there is no way that both different cat bras could be non-zero at the same time. Okay, and for that purpose, due to orthogonality condition, these extra terms goes to 0. All the extra terms which involves the product of different cat bras, they become equals to 0, and this whole square situation is simply equals to the square of individual terms. All right, so what we are going to do in here, this is a similar thing that we did in previous calculation for x cube. So here, this whole square of 5 quantities is actually equals to the square of first term plus square of second term plus square of third term plus square of fourth term plus square of fifth term. Okay, no additional terms will be involved in here because of orthogonality condition, and this condition always holds when you have this summation. Okay, whenever you are finding out the second order energy correction in time independent Schrodinger's equation, I was saying time independent perturbation theory, whenever you are calculating the second order energy correction, whenever this summation comes, this whole square is always equals to the square of individual terms, such that, okay, the condition is all the cats should be different, and that can only happen when you have simplified these cats together. Okay, beforehand it shouldn't be happened that maybe you haven't simplified it and you are getting two similar cats in two quantities, so that's not gonna hold in that situation. You have to simplify all of them so that all the cats are different. Bra doesn't matter, all the cats should be different. We can see all the cats are different. It's n minus 2 here, it's n here, it's n plus 2 here, in n minus 4 here, it's n plus 4 here. All the cats are different. So in that situation, this situation always equals to the square of individual terms. All right, and for that purpose only, I simplified all of the cats beforehand, and that is a crucial point. Before opening up the square, you are supposed to simplify all the cats so that all the cats are different. You can see in the first term it's n minus 2 cat, it's n here, it's n plus 2 here, it's n minus 4 here, it's n plus 4. All the cats are different, hence this situation holds. And yeah, square of individual terms and square of this term as well. So I'll take this outside with a square over it, and we'll write down the square of, let's do that. Actually, we are almost done, and this is we are just winding it up. Okay, it's almost done. So I'm taking h cut square, it's h cut square by 4m square omega square and a whole square over it, because we had a square over it, and we'll simplify it here outside. Now let's write the terms which are inside of it. It's 4n minus 2 under root n minus 1. Okay, I'll write the whole square over it, and keep that in mind that we don't need to put square over these cat bras because their value could be only 1 or 0. Okay, so their result square of 1 is 1, square of 0 is 0 also, so we don't need to put square over these terms. We will only put square over the constant terms. All right, these cat bras are actually the scalar products of orthogonal and normalized wave functions of harmonic oscillator. So they can either have 1 value or 0 value. So square of them is also equals to, it doesn't bring any change. So it's m and minus 2. All right, so plus, and we have square of this term, square of 3 is 9, so I'm gonna write 9 directly, and then we have 2n square plus 2n plus 1 whole square, and its cat bra is m n. Then square of these quantities, so it's 4n plus 6 whole square, and square of under root n plus 1 is n plus 1, and square of under root n plus 2 is n plus 2. m n plus 2 as it is. Square and under root cancels out, and we have n into n minus 1 and 2 minus 2 level. Okay, and this term comes as it is. Then square and under root cancels, so we have simply n plus 1 into n plus 2, n plus 3, and n plus 4, and yeah. Now we have reached a point where we are supposed to multiply this summation and this term with each of these 5 terms that are inside. So we need to multiply it. We'll take this constant as constant outside. So it's h squared square whole square, which is h squared power 4 divided by 4 to the power 2 is 16. m4 omega 4, we'll write it outside. And I'm going to multiply this summation sign and this thing with each of these 5 terms. So let's write it. Summation m is not equals to n. This m is mass and this m is general number. Okay, they are different. So you can take this whole thing outside of the summation. All right. So this is the first term, and we can separate the square over all these quantities. So it's 4n minus 2 whole square. Under root whole square is under root n whole square. Under root cancels. Here under root cancels also. It's n into n minus 1. Alright, so yeah, this is the cat bra for it. dy divided by en of 0 minus em of 0 plus, then we have 9 into this. Okay. We'll write the summation first. Then 9, we'll write what it is. 2n square plus 2n plus 1 whole square, and it's bra, which is get bra, which is this, and then the denominator, which is en of 0 minus em of 0. Then again summation, we'll do it for all these quantities. So it's 4n plus 6 whole square. We'll not simplify these terms right now. We'll do it after opening up the summation. Okay, so that we are not confusing and clustering up everything. We'll do them when we are done with the summation. Plus, then we have this whole thing. First we'll write the summation, obviously, then we'll write this whole thing. And in denominator, again, these energy differences plus summation. Finally, this video and problem is winding up. It was such a lengthy problem. En of 0 minus em of 0. So that is how we have multiplied the summation sign with each of these quantities. Now what's gonna happen is that, and okay, here you need to mention that due to orthogonality condition, you write it here that due to orthogonality conditions, this is equals to okay, only that reason is enough. You don't need to mention that what was happening. No, you don't need to mention it again and again. So that is all that was needed. Now here what's happening is that we have these get bras, and this m is running over these m values, and this product, these get bras from orthogonality condition. Okay, now let me tell you here that this is m, and let's say n minus 2 in here, and we have summation m is not equals to n, so the value of m could not be n and it could be any other value. So what happens is that when you will open up this summation, it will open up for, let's say, 1 n minus 2, 2 n minus 2, and up to so on, and a point will be reached when it was equals to n minus 2, n minus 2, and up to so on. Now this product is only equals to 1 when m is equals to n minus 2, when both of them are same. Okay, and that is equals to 1, and for all other values of m which are different from this are 0. Okay, this product is 0 for all the values of m which are different from n minus 2. Okay, that is the orthogonality condition. If you know, the orthogonality condition is that when you have when we have two different wave functions, here they represent wave functions actually of harmonic oscillator. When you have two orthogonal wave functions, then their product is always equals to 0 when they are different. Okay, when they are different, they are equals to 0. When they are same, okay, when they are same, they are equals to 1. That is what I'm saying. So when they are different, when m is different from n minus 2, they are 0. So the summation is 0 for every value of m but for n minus 2. Okay, hence this summation thing is actually equals to is only non-zero for m is equals to n minus 2. So whatever the ket is, you will put m equals to that ket, and that is it for the summation. Okay, that is it for the expansion of the summation, and all other values become 0. So that is how you are gonna decide what it is equals to. Now let's do that here. Okay, you can see here that this summation will open up for all the values of m, but it will only be equals to non-zero value. All the values will be 0 but one value in which this m is equals to n minus 2. Okay, for this quantity, so we'll put m is equals to n minus 2 here and here, here and here. Okay, this is how we'll simplify the summation for this quantity. Similarly, here we have the summation, and we can see here the situation that the summation says that m is not equals to n, and it has all different values. So here we can see that we get m, and here the ket is n. So this expression, this summation, can only be non-zero if m is equals to n, and we can see the summation does not contain the n value only. Rest of all the values are present, but m could not be n, so that expression automatically goes to 0, because we have all the values of m which are different from this value, hence there is not allowed value of m to be n. That is why it's 0 automatically for that reason. And here m is equals to n plus 2 is what will make it non-zero, so that is it. We'll put it, we'll remove the summation, and it is actually equals to m equals to n plus 2. Here also we'll write m equals to n minus 4 here, and here same happens here. Okay, so this is how the summation will open up. The summation is 0 for all the values of m except where the ket is equals to the bra from from orthogonality and normalization conditions. So for orthonormal, such wave functions which are both orthogonal and normalized are called as orthonormal wave functions. Orthonormal wave functions, or you can say the states of harmonic oscillator, of linear harmonic oscillator, only those expressions survives where m equals to its ket state. okay, where the bra state is equals to ket state. Okay, so that is what's gonna happen. Let's do that. Let's write it down here. H cut 4 by 16 m4 omega 4, and we'll write down this expression, this whole expression, 4n minus 2 whole square, n into n minus 1, and we'll write n minus 2 here because that is what the value of m could be. In the denominator is en of 0. You don't need to write the summation now because this is the effect of summation that made all the quantities 0, but this on when the bra is equals to ket. So en of 0 minus em. What is m? For this particular value it's n minus 2. Then plus sign, you'll do the same thing for all the values in here, whole square. Okay, this is already 0. That was already 0. Next term, this is the next term, 4n plus 6 whole square, n plus 1 into n plus 2. Instead of m, you'll write n plus 2. Okay, and that is divided by en of 0 minus e. Its m is n plus 2, so plus sign. Then we have third term, which is this. Let's write down their constants first. Okay, it's ket is n minus 4, so it's n minus 4, n minus 4, and here it's n minus 4 of 0 plus the last term, which is this. Let's write down the constants first. Then we have n plus 4 because its ket was n plus 4, so it's en of 0 minus en plus 4 of 0. Yeah, that is it. And they, from normalization condition, they are actually equals to 1. So these ket bras are actually equals to 1, and we are left with these constants and these energy differences in the denominator. Let's find out these energy differences separately, and let's put them here and simplify this expression now. And for energy expressions, we have this relation. Okay, that is the energy expression. En of 0 means that is the 0th order energy, which is actually the energy of unperturbed harmonic oscillator. And 1D harmonic oscillator, in 1D harmonic oscillator, we have EP of 0 to be equals to P plus 1 by 2 H cut omega. I'm using P just to make difference between N and P so that you may not confuse. And let's calculate all the energies that we need in here. So first we need En of 0. Let's calculate En of 0, and for that purpose we'll replace P by N simply. Okay, replace P by N, and wherever it's P you'll write what is in here. So it's N plus 1 by 2 H cut omega. Next we have En minus 2. It's n minus 2 here of 0. So here instead of P, wherever it's P, you'll write n minus 2. So it's n minus 2 plus 1 by 2 H cut omega. Don't simplify it. Don't need to simplify it because when we'll subtract it, many things will cancel out. So it's En of 0 that we already calculated. En plus 2 of 0. Put instead of P, put n plus 2 plus 1 over 2 H cut omega. Then we have En minus 4 of 0 in the third term, and then this. So n minus 4 plus 1 by 2 H cut omega. And last one is En plus 4 of 0. N plus 4 plus 1 by 2 H cut omega. Now we need to find out their subtraction. So En of 0 minus En minus 2 of 0. Let's do that. So what is En of 0? It's this. I'm taking H cut omega common because they are common. And we have n plus 1 by 2 first. Then we have En minus 2, which is this, n minus 2 plus 1 by 2. So minus bracket, because it's minus, so you are supposed to use the bracket. It's h cut omega n plus 1 by 2 multiply minus inside, so sign changes, minus n plus 2 minus 1 by 2. 1 by 2, 1 minus 1 by 2 cancels out, minus n plus n cancels, so it's 2 that is left, so it's 2 h cut omega. Alright, now let's find out the next difference, which is en of 0 minus en plus 2 of 0. Since it's minus, the signs of the next term changes, so I'm going to do it directly so that we can do it quickly. So it's n plus 1 by 2 for en of 0, then minus, we have en plus 2 of 0, which is this. So I'm going to change the sign of these inner terms, minus n minus 2 minus 1 by 2, because it's negative, so it will change the signs of this quantity. Minus n plus n cancel, plus 1 by 2 minus 1 by 2 cancel, it's minus 2 h cut omega. Then we have en of 0 minus en minus 4 of 0. Let's do that. En of 0 minus en minus 4 of 0. So it's h cut omega n plus 1 by 2 minus, what is en minus 4? It's this. So let's change the signs inside. It's minus n plus 4 minus 1 by 2. Minus n plus 4 minus 1 by 2. They cancel out. It's 4 h cut omega. Now we have the last term, so en of 0 minus en plus 4 of 0, and plus 4 of 0, it's h cut omega n plus 1 by 2, and if you change the signs, it's minus n minus 4 minus 1 by 2, cancels, it's minus 4 h cut omega. We have found these differences, 2 h cut omega minus 2 h cut omega, 4 h cut omega minus 4 h cut omega. Let's put them into this expression. Let's do that. H cut 4 by 16 m4 omega 4, and we have 4n minus 2 whole square. Let's open up the square. It's 4n whole square, which is 16n square plus 4 square minus 2ab, which is you know that it's equals to actually this quantity, 2 into ab. So we write it 16n square plus 4 minus 2 4s are 8, 8 2s are 16, and minus 16n. Then we have n into n minus 1, multiply n inside, so it's n square minus n. This was 1, so we don't need to write it, divided by 2 h cut omega, it was equals to 2 h cut omega. Then plus sign, okay, this is the plus sign. Then we have a whole square of this quantity. Let's open up the square. 4n square, which is 16n square, 6 square, which is 36, plus 2 into 4 and into 6, which is 6 2s are 12 and 12 4s are 48. And next we have n plus 1 into n plus 2, multiply them together. First we'll multiply n with n plus 2, so it's n square plus 2n. Then we'll multiply 1 with n and 2, so it's 1, multiply by n, it's 1 into n is n plus 2. Alright, so divided by minus 2 h cut omega, plus this was 1, so don't need to do that. You can do this multiplication in your convenience. Okay, I can't elongate that video so much, because that's basic multiplication, that is why I'm not adding that much detail. Multiply n with n minus 1, so it's n square minus n. Okay, n square minus n. Then we multiply n minus 2 with n minus 3. Let's do that. So it's we'll multiply n with n minus 3 first, so it's n square minus 3n. Then we'll multiply minus 2 with n and minus 3, so it's minus 2n plus 3 2s are 6. It's 1 already. And we have divided by 4 h cut omega. Then we have plus sign. Let's multiply pairs together. and first we'll multiply n plus 1 with n plus 2, so it's n. First multiply n with n plus 2, which is n square plus 2n. Then multiply plus 1 which n with n plus 2, so it's plus n plus 2. Multiply n plus 3 with n plus 4, n square plus 4n plus 3n plus 12, okay, divided by minus 4 h cut omega, right? Yes. Okay, now next what I'm gonna do is to take 2h cut omega. I'm gonna take 2h cut omega as common. Okay, we'll take 2h cut omega common. We'll multiply these terms together. Okay, so if we take 2h cut omega common, so it's gonna be written here 2h cut omega, and it will be eradicated from here. Here this is negative sign, which will make this quantity negative, so it's negative here. And 2h cut omega was taken common, so only 2 was left, and this is negative, so it will make this quantity negative, so it's 2 in the denominator. Okay, now let's multiply them together and see what we are gonna get after simplification. Well, this is what we have so far, and I have rewritten all of these things. Now let's multiply them together, and before multiplying them together we can see some things that could be solved. Like you can see here, it's minus 3n minus 2n, so they can be added to give minus 5n. So it's a single quantity, minus 5n. Similarly here it's 2n plus n, which is 3n, and here 3n plus 4n, which is 7n. Okay, so that will help. Other than that, we doesn't have any term that could be solved further. Now let's multiply these terms together, and here we can see this h cut, and one of them cancels out, so it's 3 now. H cut cube divided by 16 into 2, which is 32. M4, omega 4, and one more omega, so it's omega 5. Now let's multiply them together. First I'll multiply 16n square with n square and first, and then with minus n, so it's 16 and 4. Okay, and 16n square into minus n is minus 16n cube. Then we'll multiply plus 4 with n square is 4n square. Then plus 4 with minus n, and it's minus 4n. Minus 16n with n squared, it's minus 16n cube. Minus 16n with minus n, it's minus minus plus 16n square. Plus. Alright, so this is negative sign. Then the bracket starts, because it's negative sign, it will change the sign inside. So 16n square first will be multiplied with n square, which is 16 and 4. 16n square multiplies with 3n, which makes 48n cube. Then 16n square multiplies with plus 2, so it's 32n square. After that, we'll multiply 36 with n square, it's 36n square. 36 with 3n, which is 108. 108. 36 with 3n, so it's 1n only. 108n. After that, we have 36 with 2. 36 into 2, which is 72. No n, because it's simply 36 multiplied by 2. So yes, that is it. Oh, okay, sorry, we have 48n as well, so we'll have a plus sign. Plus 48n into n square, so it's 48n cube. 48n into 3n, 48 into 3, which is 144 n square, and 48 n multiplied by 2, which is 96n. If you are wondering that how I know that, I have solved it beforehand. I solved it beforehand. I completed it first, so I'm doing it now in neat form for you people. Such lengthy calculations always accompany many mistakes. There is always a greater probability of having mistakes in it, and solving it beforehand is always a good idea. I'm taking 1 over 2. This is this whole term divided by 2, so I'm taking 1 over 2 outside, so it's 1 over 2 into bracket starts. We'll multiply n square with these three quantities first. N square into n square, it's n4. N square into minus 5, n is minus 5 n cube. N square with plus 6 is plus 6n square simply. Then we'll multiply minus n with n square, which is minus n cube. Minus n with minus 5n, which is plus 5n square. Minus n with plus 6 is minus 6n. Alright, so bracket we close. Then we have this negative sign. I'm taking 1 over 2 outside. Okay, let's multiply these terms together. We'll multiply n square with n square, n4. N square with 7n, 7n cube. N square with 12, it's plus 12n square. 3n, next is 3n. 3n with n square is 3n cube. 3n with plus 7n is 7 3s are 21 n square, plus 3n with 12 is 36 n. Yes. Then 2. We'll multiply 2 with n square, so it's 2n square. Plus, we'll multiply 2 with 7, it's 14n. We'll multiply 2 with 12, it's 24. In this way, this whole thing is done. We have multiplied them. Now we need to multiply these negative signs inside, and we need to simplify the terms together. And for that purpose, let's multiply the negative signs inside and add up the terms which could be added. So it's h cut cube 32 m4 omega 5. So first is 16 and 4 minus, I'm not simplifying it right now, we'll simplify after multiplying the negative signs, and I'm just writing it again. Well, we have written these terms. Okay, now I'm multiplying this negative sign inside, and we can see all of the terms are positive, so we have negative with all of these terms up to 96n. Okay, so let's do that. Negative sign 16 and 4 minus 48 n cube minus 32 n square minus 36 n square minus 108 n minus 72 minus 48 n cube minus 144 n square minus 96 n. Next we can see that we have a plus 1 by 2, and 1 by 2 is multiplying with all these terms, so let's multiply 1 by 2 inside and write them outside of the bracket. So 1 and 4 by 2, it's n 4 by 2 minus 5 by 2 n cube. Just write 2 in the denominator of each of these terms, so that is it, square by 2 and minus 6n by 2. Now next term has negative sign with it as well, so we have the change of signs. They will all be negative because they're all positive right now. So if we multiply negative inside, so they're all negative, and we'll write 2 in the denominator of each of these terms. So let's do that. Minus n 4 by 2 minus 7 n cube by 2 minus 12 n cube, n square, 12 n square by 2 minus 3 n cube by 2 minus 21 n square by 2 minus 36 n by 2 minus 2 n square by 2 minus 14 n by 2 minus 24 by 2. So these are all the terms that we have in here. Now we need to add, subtract, cancel whatever happens in here. First of all, let's see the n4 quantities, all those terms which have n4 in them. Okay, this is the first term we can see, and this is n4 term. It's plus 16 and 4, it's minus 16 and 4, they are cancelled. That's a good news. And we can see that this is plus n4 by 2, and this is minus n4 by 2, they will be cancelled out. And there is not any other term which have n4 in them, so this is solved. Now let's see the terms which have n cube in them. So I'm underlying all those terms which have n cube in them. So it's minus 16 n square n cube, minus 16 n cube, minus 48 n cube, minus 48 n cube, minus 5 by 2 n cube, minus n cube by 2, minus 7 by 2 n cube, minus 3 by 2 n cube. Yeah, these are the terms which have n cube in them. So let's write them together and we'll add them using calculator. Okay, so I'm writing them like that. I'll not write n cube with them. Okay, I'll write n cube outside. So minus 16, minus 16, minus 48, minus 48, minus 5 by 2, minus 1 by 2, minus 7 by 2, and minus 3 by 2, and n cube outside of it. Okay, we'll add them up later. Let's write them all the terms together first. Next we have n square terms. I'm cancelling these terms so that we may not consider them again. Now we'll underline all those terms which have n square in them. So 4n square, 16n square, minus 32n square, minus 36n square, minus 144n square, this 5 by 2n square, minus 12 by 2n square, minus 21 by 2n square, minus 2 by 2n square. Yes. And for this we can see 2 and 2 cancel, so it's n square simply. And let's write them together. Bracket stars, first is 4. We'll not write n square, we'll write n square outside. So it's plus 4, plus 4, then red lines, okay. Plus 16, minus 32, minus 36, minus 144, plus 5 by 2, minus 12 by 2, which is 2 ones are 2 and 2 6 are 12, so it's minus 6, minus 6, and minus 21 by 2, and it's minus 1 because 2 and 2 cancel out, so it's 1 only, into n square. Now we need to collect all those terms which have n in them. So I'm gonna use blue marker. Minus 4n, minus 108n, minus 96n. Oh, it's n square term. 6n square by 2, we didn't consider that, so we need to write it. I missed it. Okay, this is also n square term. 6 by 2, which is 2 ones are 2 and 2 threes are 6, so 3 is also here. I'll write 3 here. In n square terms we missed this one term. Okay, before 5 by 2 is this n square term as well. So all the red lines were n square terms, so we missed this one. Okay, you can write it here. It's plus 3. Now we were underlining all the n terms, so it's minus 4n, minus 108n, minus 66, 96n, and this minus 6 by 2n, this, and this. Let's write them together. First is minus 4, minus 108n, minus 108, then blue, underline blue, minus 96, minus 6 by 2, 2 ones are 2 and 2 threes are, so it's minus 3. Then this 2 ones are 2 and 2 18s are 36, so it's minus 18. 2 ones are 2, 2 sevens are 14, so it's minus 7. It's n terms. Now we will write the constant terms, the terms that are left behind, and we can see it's minus 72. And other than that, it's this, which is 2 ones are 2 and 2 12s are 24, so it's minus 12. That is it. These are the terms. Now let us all add these terms together, these together, and then these. Okay, let's see what we get after adding up these ones. We can see we got minus 136, minus 136 for n cube. All right, next we have these terms. Let's add them together. Here you can see we got minus 204, minus 204 for n square. Next is these n terms. Let's do that. It's 236 minus 236 and minus 224 and 84. So that is what we got. And here we can see that we can do one more thing. Let's divide. All these numbers are divisible by 4. So what we can do is to multiply 4 here and divide 4 inside. Or we can divide actually. Yes, yeah, that is okay. So let's see, 136 divided by 4. What does that equals to? 136 divided by 4 is equals to 34. Okay, we will write it in later step. 204 divided by 4 is 51. 236 divided by 4 is 59. And this last term, 84 divided by 4 is 21. We'll write these in later step, and here we can cancel out something. 4 divided by 32. Okay, we can divide 4 by 32, so it's for 1s and for 8s, so it's 8 in here. Let's write it in later step. We are just trying to get a simpler term, so it's h cut cube divided by 8 m4 omega 5, and we have minus sign. Okay, with minus we have minus 34 n cube, minus 34 n cube, minus 51 n square, minus 59 n, and minus 21. Yes, that is it. Let me see that whether they are divisible by 3 or not. No, they are not further divisible, so that is the final form that we have in here. Yes, that is the final form, and this is the result that we got for actually this term, which is m is not equals to m x x4 n whole square divided by en of 0 minus em of 0. So that is the expression that we successfully got, and it is actually equals to h cut cubed by 8 m4 omega 5 and minus 34 n cube minus 51 n square minus 59 n minus 21. So that is the result that we got for this summation. And we got, if we refer to the result that we got, and we can write, and we had the result that we got for cube. Let me write it here as well, because now we are gonna put it into the equation where we started, from where we started. So it's h cut square by 8 m cube omega 4, and it's minus 30 n square minus 30 n and minus 11. Okay, so that was this, and this is this, and let us put it right back into the equation. Here's the equation number 2. We have successfully calculated this part and this part. B square and a square are the extra, they're all there. So we calculated this and this. Let's put it into this equation number 2, and we have actually attained the result that we were seeking. We just need to put in here, and we have got the result it's En of 2 second order energy correction, that is equals to a square. Okay, first is a square times this result, which is this. So let us write it, h cut square divided by 8m cube omega 4, and we have minus 30n square minus 30n minus 11. Then we have this plus sign plus b square. Okay, and inside and these are constants, h cut cube divided by 8m 4 omega 5, and we have these constants that are being multiplied, minus 59 and minus 21. We can do one other thing, that we can take this negative sign outside, so it's minus a square h cut square by 8m cube omega 4 30n square plus 30n plus 11 in negative. All of them are negative, so I'm taking negative outside. So b square h cut cube by 8m 4 omega 5 bracket starts, first is 34n cube plus 51n square plus 59 and n plus 21. So that is the second order energy correction for the nth state of linear harmonic oscillator. This is the second order energy correction for the nth state of linear harmonic oscillator with perturbation, which is h bar equals ax cube plus bx 4. All right, and we can see that the correction is negative for all values of n. So it will act to reduce the energy of the unperturbed harmonic oscillator. So because it's negative, you can see here that we have this negative, and none of the other quantities can make anything in here to invert the sign. We can't do that. We have a square as positive quantity, h cut square as positive quantity, m mass is always positive, omega 4 even powers mean a positive quantity. Here everything is positive, even the n states are also positive. They cannot be negative, so they are positive. Here all of them are positive, so these negative sign will stay there, and the overall result that you are gonna get will be negative as well. So whatever the for example, if 20 is the energy of the unperturbed harmonic oscillator, and I don't know about its first I just don't remember what was the first order energy correction, but the second order energy correction will be negative. Maybe it's -3, so it will actually reduce the overall energy. It will act to reduce the overall energy. So that is what I was saying here, because it's negative. And by putting values of n, we can get second order energy correction for any state of harmonic oscillator. If you will put n is equals to 0, which is the ground state, okay, if you put n is equals to 0 in this formula, you will get the second order energy correction for the ground state of linear harmonic oscillator under this perturbation that I mentioned. And if you put n is equals to 1 into this formula, you will get the second order energy correction for the first excited state of linear harmonic oscillator with under the perturbation that we mentioned. And similarly, if you put n is equals to 2, you will get the second order energy correction for the second excited state of linear harmonic oscillator. So the things will go on. So this is the general formula, and that's the a really universal formula, because you have got the tool, or you can see you have the prepared form. You just need to put the value of n and you'll get the energy correction for any state you are interested in. So that is it for this video. I hope you got it, and I tried to make it as descriptive and as detailed as possible, because there are so many chances of getting into mistakes, and because there are so many terms involved, and I made mistakes 2 times and I had to refilm this video again from the point where I made the mistake. So that is something that is happening even with me. You have to be really careful whenever you are proceeding with the with the problem. You have to double check whether the previous step was correct or not. Always double check and then move forward, because it will reduce the probability of mistakes. And yeah, that is I have to share with you. This is something that I do during the exams as well. I always double check everything, especially when the problems are really lengthy and have complexity in terms of number of terms. So that is something that you should be doing. And even if the problem is simple, you must double check it or triple check it to ensure that you are not making any mistakes, because sometimes we are making mistakes with some really easy things. Something that I did while I was attempting my quiz for statistical mechanics problem, and that was such an easy problem, and I made a mistake in even the formula, which was so easy for me, but I never double checked it, and I lost my marks. I lost my marks because of that. So that should not happen. Always double check. Okay, keep watching my videos, because I make really helpful stuff on some of the tough things that are not even available on internet. So that is the stuff that you will not be finding anywhere else. So I recommend you people to stay tuned and follow my channel and share with others. Yes, goodbye.